Hey, everybody. So welcome to the disaster recovery talk. So this talk is going to be a 300-level talk. So some important things to know about this talk in particular. If you've come to this talk in the past, this talk is an iteration of a talk I've given a couple times in the past at reInvent as well as the summit. So there's going to be some prior content in here, but I'm going to be pumping in some new stuff for this time. The point of this session is really to understand how to leverage AWS for disaster recovery scenarios. So I'm going to show you a couple examples of how you can do it through different AWS-specific services, as well as a partner-related service towards the end. And for anyone that's ever come to this demo before, you know that I always close out with a good closer. This year is not to be missed. I went for broke, and I'm hoping it goes really well, but live demo. So with that said, let's get started. Mark Twain was quoted as saying that history doesn't repeat itself, but often it rhymes. And in disaster recovery, we see that a lot. We see people make the same fundamental mistakes over and over and over again. And what I really want to kind of stress through this whole session is that there are a number of low-hanging fruit things that I'll see a lot of people nod their head on, but you'd be amazed at the number of times I've gone into customer sites and they're still not doing the fundamentals in terms of disaster recovery and backup. So let's start with a little story. It's 1986, and we're in the area of Russia and Ukraine, and it's late in the evening, and we're going to run a little experiment. We're going to do a little live disaster test. So what we want to do is we want to find out, will our facility work when we take power out of the facility? And what we want to know is, if we increase the load on our infrastructure, will it affect our output to our downstream customers? So the scenario that I'm talking about here is actually Chernobyl. So in this case, the disaster was that what they wanted to do was run an experiment. And what they didn't do, and that we see a lot in real-world computer technology, is they started with a plan, and then they didn't tell anyone what that plan was. And so when they actually went to go and execute the experiment that they were going to run, they were supposed to do it in the middle of the day with a particular staff, and then they changed their mind. And they decided that they were going to do it later in the evening, and it was going to be at a point when the staff was going to be transitioning from the evening crew to the night crew. So in terms of disaster recovery terminology, this would be a recovery point, or our RPO. This is the point that we wish we could get back to. So what happens, as you probably know, is they start to run the experiment, and things don't go right away. They start getting indications that things are wrong. The meters, their dashboard, their SOC screen starts going red across the board. And so what do? Well, the engineers didn't know that this was supposed to happen. So they started to manually interpret the signals that they were being given. And they started to try and fix the situation by just reacting to the information that they were seeing on their screen and not holistically looking at what was going on. So between the disaster and that recovery point that we wish we get back to, in our terms, this would be data loss. This would be an area where, between our RPO and the disaster, how much data can we stand to lose before we're going to be out of business? So there was a really good quote from a fireman who was actually on site on Fire Station 2. And as they arrived on scene, basically the quote that he gave was, there's going to be an incredible amount of radiation here, and we're going to be lucky if we're still all alive in the morning. And in our terms, this is recovery time. So this is, how long is it going to take us to get back to normal, and how long is it going to be for things to be all right again? And between that disaster and that point when everything's all right again, that's downtime, and that's what we're trying to minimize as much as possible. So this would be our RTO. And yet, just as I said in the beginning, people don't learn from history. Fukushima Daiichi. So what happened at Fukushima? Same thing, actually, if you really think about it, right? It was an unplanned event, causes a coolant level failure. An uncontrolled fuel rod triggers a meltdown event. That uncontrolled fuel rod going into the reactor starts a massive amount of steam going into the reactor. And that massive amount of steam that they didn't know what to do with ultimately causes the reactor to fail. And there were generators that were present on site that could have been used to help bring that reactor back online and not inject the rods as quickly as they did. But that reactor was at the water line. So the reactor was damaged during the event as well. So the lesson learned here is that failure is not one thing. It's not a single event that's going to cause an outage. It's going to be a cascade of many things all together that you have to plan for in unison. So it's really important when we talk about disaster recovery to be honest with yourselves and really establish what is it that you are really planning for. Is this going to be a small-scale event? So is this an event where we have a single server somewhere? Maybe it's not a huge deal. It does a basic function, but when that one server goes offline, not a huge impact. Maybe this is a larger event. So we've got a number of servers across a region, an availability zone. And what happens if we start to see problems systematically throughout that area? So now we've got a larger area that we need to speak to. So now we have more and more systems starting to go offline. How do we bring them back online? How do we know what this data is actually telling us? Are we interpreting the signals on that dashboard and trying to react in real time? Or are we going to play based on a playbook of automation? What happens if it's a really big problem? So we're talking region-level outage, an area where maybe if you're doing a hybrid solution, your entire facility is destroyed in a fire or a natural disaster. So let's talk about some common techniques that we see in terms of disaster recovery. So we're all speaking from the same language. The most common approaches that we see for disaster recovery are pilot light scenario, and what a pilot light really looks like is this. We have, in this case, let's say a hybrid architecture, and we've got our on-prem architecture that's basically just replicating data to our database. So in terms of disaster recovery time, this is going to be the longest RTO, because what we have is servers that are there, but they're not running. So we're going to need to spin them up in order to actually fail over. But this is also the most cost-effective solution. We're not paying for more than we need to. And if our RTO is long enough, then this is a good way to deal with cost considerations, but not for time. So the next scenario, if we look at how this would fail over, is a warm standby. So in a warm standby configuration, it's going to look really similar to the other one. But in this case, what we're going to do is have basically the fleet there and have part of the fleet online, but it won't be at full capacity. So basically, we'll be running at a reduced load. And here we can see, again, we're doing the same database mirroring replication technique. And when that disaster happens, all we're going to do is just scale up the infrastructure so that we're able to start taking over the full load. In this case, and as well as the prior, what you're seeing is that I'm using Route 53 as a DNS cutover. So we're going to flip the DNS record to point to our DR region. And the last one is called a hot site. So hot sites, most commercial customers will try to do this. Hot sites are the most expensive solution to go because you're effectively going to run one for one. Every server that you're running in production, you're going to run in your DR region. For customers, this is a requirement because their RTO is in the scale of minutes to, in some cases, seconds. So they need their failover to be as fast as possible. And their RPO is the same capability. We're going to replicate as much as possible with the greatest frequency that we can so that when we do our cutover, the data loss will be minimal. So in that failure scenario, again, the same thing happens. The only thing that's going to change in this scenario is rather than scaling anything, we're just going to flip a DNS record. So it's important to note that when we talk about disaster recovery, I've given this talk a couple times. Some of the feedback I've seen in some of the comments has been folks are really focused on backups. Disaster recovery is not just backups. We're going to talk a lot about techniques for moving data back and forth, but it's important to know that part of the DR process is dealing with business continuity. So what's going to happen in the event of a failure? Are we properly designing our infrastructure for high availability from the initial design of the infrastructure? So do we have just one server running in our prod environment, and then are we going to replicate that single point of failure in our DR environment? We're going to have the same problem if this is a very large-scale event. So I work with the public sector, and when we used to give these talks, we used to jump right into the most complex scenarios that we see with customers, and I didn't like that. I want to start with something that everybody in this audience can use, from a small startup to a group of folks that are just getting started on AWS. So I want to show you guys a basic backup and recovery use case. So the simplest and easiest way that we can do this is with the AWS CLI. So in this case, what I'm doing is I'm running an AWS S3 sync of a directory. In this case, it's a backups directory. And what we're doing is we're just replicating that data to an S3 bucket, in this case, my bucket. If anyone here has ever used Linux before, the second command will look a lot like an rsync command. So in this case, I'm doing the same operation, but with a sync command. So it's going to keep the two in state with one another, as well as the third one includes the delete option. So now I'm saying if a file was present and is no longer present, delete it from the bucket. So I'm getting a one-for-one match. But you also see that I'm adding a different attribute there, which is changing the storage class. So in this case, what I'm doing is I'm setting this to a lower storage class, which was the infrequent access, because this is just a backup for us. So our scenario is that we're not going to probably use this very much, so we want the most cost-effective solution. So what does it look like when we actually do this? So this is an example workflow. So we've got a user at a remote location that's replicating this data over to S3. It can go to the bucket. We can set a lifecycle policy on that bucket to automatically tier that data over to a service like Amazon Glacier or infrequent access, so that if we know that we're not going to access data after a certain time window, we can move it to a more cost-effective data tier. When we want to get data out of this scenario, what would it look like? So the first way is that we could pull directly, obviously, from S3 the same way we pushed it in. But in a DR scenario, what we're presupposing is the reason that you're doing that is because something went wrong in your infrastructure. So in this case, what we can do is basically take that same novel infrastructure that you have in your environment and start running it inside of an AWS region. In this case, what I'm showing is you have a VPC endpoint. So we're trying to pull as quickly as we can through that VPC endpoint without exposing anything to the public internet before we're actually ready to go into full prod. Then we can light up an internet gateway and re-expose our service if that's what we want to do. What would this cost? So in this case, what I'm showing you is 10 gigs of S3 data, 100 gigs of infrequent access data, and a terabyte in Glacier. And it comes out to about $550 a month. So crazy cheap. It doesn't take a lot to do this. But in terms of RTO, RPO, there's going to be a lot of manual work into actually making this work. You're going to have to move servers. You're going to have to spin up servers manually or write a script. So not really complex, but it's good for, we just need a way to back up. So let's talk about a larger data archive and recovery operation. So if we look at larger, medium-sized business now, maybe like someone that's doing genetic analysis or small-scale scientific research, we can use that same technique that we saw in the past example. So AWS CLI, copy our objects to our bucket. But if we need to ingest data much more rapidly and we're constrained by the pipe in our facility, another technique that we can use is a snowball. So if anyone's never seen the snowball, we've got them down on the expo floor. Go check them out. You can, they might let you throw it off the table if you ask really nicely. But they're these hardened devices that effectively you bring on-prem. You can mount them to your environment, copy the data. It has a Kindle e-ink screen on the front. And when you're done with your copy operation, the screen will change. And it will go back to an Amazon facility that you chose. And we will take that data and put it into the S3 bucket that you've predetermined for us. So it's a good way for moving large amounts of data to AWS. And because it's an S3, again, we can use that same lifecycle policy to do something like move it to Glacier. Another technique that we can use is the storage gateway service. So in this case, what I'm showing you is a couple different techniques. One is we're using the cache volume mode, and what we're doing with that is presenting it as an iSCSI block device to our server. So the server itself sees it as like a hard drive, and we're just writing to that, and that's basically then copying the blocks up to S3. Now when I say copying the blocks up to S3, one area that we also saw some confusion on in the past, that's an S3 bucket that the service maintains. So that's not a resource that you see in your account. We're just using S3 on the back end at the service layer, so you won't see it in your S3 bucket. Likewise, if you want to replace your aging tape infrastructure, the VTL mode will allow you to basically present a virtual tape library in your environment, and those tapes will be written likewise to the storage gateway and can be archived in either S3 or Glacier based on your cost considerations. The other way that we can do it now is the file gateway. So the file gateway is a little bit different. Instead of using a block device, the file gateway will present itself as an NFS mount. So now basically the server still sees this drive, but we're basically taking that data and writing to it like normal. But now the data is being written directly to S3. So the advantage here is that when I want to do things like cross-region replication now, it's an S3 bucket. So all we need to do basically is configure the bucket policy so that I lifecycle that object into either my other region or into a different storage class. So what would recovery look like? Well, obviously, if we're going to use something like the snowball, it's going to look very similar. What we're going to do is take the snowball and do an export job and then take it back to either your facility, or again, we can use AWS as your DR region. If we're looking at using the storage gateway as a DR region, the process is very similar. So in this case, what we could do is we could fail back on-prem, or we can actually spin up an EC2 instance inside of a VPC, and there's actually an AMI that we can install that will allow you to use the storage gateway on an EC2 instance. And at that point, what we can do is take the EBS volume that's being written from the storage gateway, mount it, extract the data from the host, and then start our DR process. And then again, the other way, as I mentioned, is a direct AMI that uses the storage gateway service. Could be a completely different region where the original S3 bucket was written as well. The file gateway is, again, very similar. In this case, basically, we would take the data and rehydrate it back on-prem or to our DR location that we want to use. Likewise, if we wanted to use the Snowball device, again, that's the mechanism that we'd use for the recovery. Or, again, we could use EC2 in a separate region and, again, pull directly from that S3 endpoint so that we don't expose the service until it's actually online. So what does this cost? So a little bit more expensive, about $1,900 a month, but in this case, we're backing up more data. 10 terabytes on the file gateway, 32 terabytes on the storage gateway, and about 250 terabytes on the VTL tape library. So this is a per monthly cost, but again, allows you a pretty decent amount of orchestration, good capabilities. RTO is fairly reasonable, RPO is fairly low. In this case, if we also looked at the Snowball-based solution, if we wanted to move a large amount of data, what would that look like? In this case, what I'm moving is a petabyte of data from S3. So you can see the cost is a little bit higher, but in this case, it's a one-time cost. So it would be the export cost, and then the monthly cost would be a little bit lower. For a petabyte, would be about $4,000 a month. So if anyone here doesn't work in large-scale storage, you probably know that procuring a petabyte of storage that has the same durability and availability as S3 is not $4,000 a month. So this is a really good cost-effective way to get that. If you need to move even more data, last year we announced the Snow Machine, or the Snowmobile. So in this case, the Snowmobile can move up to 100 petabytes per Snowmobile. And we actually have a couple good customer use cases for doing just that. So let's talk about on-site virtualization, replication, and failover. So the first time I gave this, I wanted to call out, this is a colleague of mine, Jamie Butler's. And what he had was a customer that was an educational customer, and they were very cost constrained. And their facility was a facility that, if I remember correctly, it was at the end of a runway, underground, with pipes running overhead where aircraft had previously crashed, and there was actually a leaking pipe in the facility. So what they wanted was a DR solution that would allow them to basically take that data and actually run true DR on AWS when an event happened. But they needed a very cost-effective way to do it. And when they went out to third parties, the solutions that they were getting were astronomically expensive for their budget. So there's a really neat feature that some people don't know about VMware. So there is a function in VMware where you can stand up a replication appliance. And what the replication appliance will allow you to do is basically take that VMware infrastructure and replicate it to its storage volume. But in this case, we're tricking it. We're using the storage gateway as that iSCSI mount point for the replication appliance, and that's being copied over to the storage gateway service on our side. So in the case of a disaster, what they're doing is they're taking that data that's coming through that service, and then they're taking the EBS volume that's coming through the stored volume. And what they'll do is use the VM import-export service to allow them to convert the VMDK into an Amazon machine image, and then they scale out their fleet. Now, the first time they did this, my understanding was this was mostly a manual process. And my current understanding is that they've basically automated this entire process. So when the event occurs, their time and point objective are fairly low. They kick off an automated CloudFormation template that starts to spin up the pipeline that does the conversion for them. And then I believe they make a outside of band DNS change to actually point their customers to this resource. So what would something like this cost? So this came out to about $753, which for them, that was huge. The solutions that they were looking at for this were deep into 6 digits. So this was a major cost savings. And in this case, what we were looking at was 32 terabytes of data that was being moved over the storage gateway. We all know, hopefully by now, VMware and AWS have a strong partnership. So there's some really cool solutions now that you can use in terms of actually having your disaster recovery run on AWS, but provided by VMware. So I would encourage you to talk to the VMware folks that are down on the expo floor, but suffice to say, what you're capable of doing now is basically running your existing infrastructure as you have without making any dramatic changes. And through that partnership, you can now extend that infrastructure into AWS for your DR, so do your VM replication or live migration to AWS. And the reason that that's kind of cool, outside of the fact that it's a facility that you don't have to pay for, is that now that those resources are running in an AWS environment, we can plug them into other AWS resources directly, like a VPC, or we can have it talk directly to the S3 service. So from a cost-effective perspective, there's some really cool capabilities there. So let's talk about a high availability Windows Server storage problem. So really simple example, we've got a data center that has a storage gateway backend, and what this is just a Windows server serving out SMB, and we're using the storage gateway in that iSCSI mode, and that's basically just replicating to a different part of the country. So in this case, the customer maybe is on the East Coast, and they've chose to have their DR on the West Coast. So what they're really worried about is sort of that backup scenario of what happens when our primary data center goes offline and I need to be able to interact with the service again. I can pull it just as I showed you before directly from the storage gateway. But this one I wanted to share with you guys this year is pretty kind of trick. So a good example again of someone kind of making a hack of one of our services, but it's really clever. So in this case, the customer wanted to do something where they had to have a SMB support for Mac and Windows-based clients, so that's full SMB v3. And what they figured out was that they could use a Microsoft server and use a pair of the storage gateway devices. And basically, each storage gateway device was writing to a separate pool. And what would happen is that they would have effectively 2 copies that were then being stored on AWS. And they were using the Windows distributed file system on the actual server to basically strike between the 2 hosts. So now basically they have replication between 2 independent servers, and the block data, instead of actually paying for this large SAN array, they're using storage gateway to basically fill that need of that storage appliance. So in this case, the DR part was also kind of trick. So what they did is they ran basically another host in AWS, and the Windows server will allow you to basically replicate the data down to another target. So in this case, they had another Windows server that they were using to replicate the data. And again, you can use the storage gateway inside of AWS, so they had that same block device inside of AWS replicating to a separate region. So they had effectively like 3 copies of the data now. So this was kind of a trick example. So what about multi-site replication and failover? So this year, we made a really significant change to Direct Connect that we didn't have last year, which is that you can now have a Direct Connect in your facility and have that connection go not only to the nearest edge location, but to other locations across AWS's ecosystem. So in this case, what I'm showing you is a more traditional large-scale enterprise customer where they have a corporate data center, a Direct Connect, and they're effectively treating AWS as a hybrid data center. So they're using us for services to fill in the gap where their compute storage needs to basically run at a more flexible level than what they did in their on-prem data center. So in this case, I'm also using a VPN fallback. So if the Direct Connect were to go offline, we can fail back to the VPN connection. So how do we deal with DR in this scenario? So in this case, what I'm doing is first doing things like AMI replication from one region to another. I can also do things like EBS snapshot, so I can snapshot that volume and copy it from one region to another. And when we have a disaster, because this is a larger environment with more complex servers talking to one another, what we would want to do is use a service like CloudFormation to quickly reconfigure the environment based on a blessed known configuration. So this would basically ingest those EBS snapshots. We could take in those AMIs that have been copied and then use that as part of the CloudFormation template to effectively spin these servers back up and put them in the appropriate security groups, the appropriate routing groups. And the idea here is that basically when we're ready to spin the services back up, we can now directly connect that Direct Connect to our failover region. And if for some reason the Direct Connect line was damaged as part of our disaster, we could still use the VPN connection to plumb that into our DR area as well. The reason, again, that we want to use the CloudFormation template in this example is the first example that I gave you about Chernobyl, right? So people manually interpreting signals on their dashboard and trying to quickly address it, that's a bad time to actually make gut decisions. You want this to be automated as much as possible. So what would something like this cost? So in this case, I'm showing you a moderate 1 gig Direct Connect, VPN fallback connection, a couple EC2 instances, and roughly this came out to about $561. So obviously, the more complexity that we add, the more servers. If we're going to use a larger scale Direct Connect, that also might add a little bit more cost, but fairly nominal. So another scenario that comes up is that some customers don't think about disaster in terms of what happens to our people. So in this case, I want to talk about knowledge worker disaster recovery. So we've all talked about at this point things like servers and storage, and how do we get our servers and storage back. But what happens when you walk into work on Monday, and this is what you walk into? I'd call this a disaster too. So now we have all these knowledge workers in our environment that no longer have compute resources that they can actually perform their job duties on. How do we get them back online? So some folks know we have a service called Workspaces. Workspaces will give you a virtualized desktop running on the AWS infrastructure. And in this case, what we can do is we can use that Workspaces in the same design as that prior corporate example, where we're using a service like Direct Connect or a VPN to replicate our core server infrastructure to AWS. And then we can also do things like, again, use the storage gateway for tape library replacement. So when that outage occurs, what we can do is we can offer our knowledge workers a workspace client. And that workspace client will then connect directly into that same VPC where we've been replicating all of our compute and server infrastructure. So to them, it will be more or less transparent. Their desktop profile, if you've named roaming profiles, should be the same, so they'll still get the same desktop experience. But the other thing that's really important to call out in a scenario like this that a lot of people don't consider is, sure, you could go out and allow every single user to use their own device, or you could allow them to use small Chromebook. But the problem with that scenario is, especially for highly regulated customers, what happens when you want to look at things like compliance, like, well, do each one of those devices have encryption? Do each one of those devices have a solution like an antivirus solution, something, again, from a regulation perspective? In Workspaces, we can bake all of that into the image so that it's the same, just like in our corporate environment. The other thing that's really cool about Workspaces is that it's platform agnostic. You can run it on a Mac, you can run it on a Windows host, you can run it on an iOS device. The other nice part is that we don't have to worry about, is the data leaving our facility? So now we have all these workers maybe spread out across our area, and all that the end user is seeing is pixels, because that's all we're pushing over the wire. There actually is no data that's going to the end user. It's just using the PC over IP protocol. So if we did this for 30 days using 25 users in a moderate Active Directory environment, it comes out to about $1,500 a month. So this wouldn't necessarily have to be an ongoing cost. That Workspaces cost could be reduced when we're not actually using them. But I can assure you that if your recovery time in order to get into a new office space is about 30 to 60 days, this is a much cheaper solution than going out, procuring all new laptop or all new desktops, re-imaging them, and then trying to deliver them to your entire worker fleet. You can do this much faster and much more easy. The next one I want to give you is a compliance disaster recovery example. So I don't see enough examples about this, especially in government workspaces. So AWS has a large number of assurance programs that we offer for everything for customers in healthcare to highly regulated financial institutions to folks that work in law enforcement and the intelligence community. So how could we deal with compliance failover? So in this case, I'm working with a government partner, and they have very stringent requirements with the way that our data center must be configured. So we're susceptible to things like NIST. So what you've probably seen in the recent news is that there's been this large wave of attackers that are going in, and they're dropping malware that will effectively either ransomware the computers away, or even more maliciously, they won't give you the opportunity to back up your data and save it, they'll just wipe it out. So in this case, we lose our entire facility to one of these actors. How do we then come back? So you could have that hot site, but that's going to be crazy expensive to have two facilities that can meet those high standards for NIST or PCI or HIPAA or whatever your compliance regime is, right? So on AWS, we have a number of quick starts that are available that will help accelerate getting you to a compliant framework. So inside one of these quick starts, let's look at the NIST one. So the NIST one speaks to, for example, 853, 800-171, FedRAMP, and the DoD SRG. So using this template, as well as a neat little function that we give you, which is the Cloud Security Control Matrix, which is in that block text at the bottom, we'll provide you basically with a kind of click button ability to spin up an environment that will meet these regulations and tells you basically where AWS is responsible for control and where you are responsible for control. So in this case, again, if our compliance was SOC, CGIS, PCI, FedRAMP, we can use AWS as our DR failover that will allow us to be compliant with those capabilities, take those resources, spin them up on this side, still interact with our government partner, and still meet our obligations. So every example I've given you up to this point has been really focused on solutions that are hybrid or solutions that are mixed mode. Well, what happens if you've made the choice to go all in on AWS? So let's do a little cloud lightning round. So the first use case I want to talk about is you've made the decision to run all in on AWS, but you're running into technical limitations. So we can do things like snapshot EBS volumes, but I want to make sure that when I snapshot the EBS volume, I don't lose data. So there was a really cool blog post that we put out, and effectively what the blog post will show you how to do is make sure that prior to performing the snapshot, we freeze the file system so that we can get a full snapshot of the volume, so everything that's actually being used is written to disk and persisted, so that when we actually go and perform the snapshot, we've actually got everything in the environment. So what happens when we want to deal with things like EC2 instances crashing? So host goes unhealthy, there's a resource that just becomes unavailable for some reason. How can we deal with recovery a little bit more easily for EC2 services? So in this case, what we can do is use the auto recovery capabilities. So what I'm showing you is we've got a status check system failed, and then what we're going to do is set your failure threshold. So in this case, I can say the number of times that I'll get an unhealthy check before I'm actually going to kick off a process. And then here you can see that what I want to do is recover the instance. And the recovery instance is actually pretty slick, because if it had things like an attached network interface or any other drives attached, when it comes back, it'll be in that same state. And then we can set our period of basically looking for that statistic. So if we want this to be a very tight RTO, we'll make this a much lower number. If we have a longer RTO, RPO, we can make this a higher number. And we can do the same things if a machine hangs. So the machine didn't crash, but something has gone wrong and it's just not responsive. So we can do the same procedures, but in this case do an auto reboot. So bring that host back online doing that. What if what we're worried about is S3 data loss? So out of the box, S3 is built for 11 nines of durability. You can basically store 10,000 objects for about 10 million years before you run the risk of losing one of them. It supports cross-region replication, as I mentioned earlier. So what we can do is we can make sure that we replicate from one coast to another, from one continent to another, if our service allows that. A neat function that we also enabled now is versioning. So within the S3 service itself, you can version the objects so that if a user accidentally deletes an object, overwrites it, or corrupts an object, we can pull back to a prior version. We can also do things like, if we're in a regulated environment or we're using S3 for storage of log data, enable functions like MFA delete, so that the only way to delete an object is that you have to have a second factor of authentication and an MFA capability. And of course, IAM roles can also be used to limit access to S3. So we can make sure that if this is our DR account, we're only allowing authorized individuals to interact with the service as well. As you probably know, if you're using RDS, RDS has a number of mechanisms that will allow you to do replication. So there's RDS automatic backups and snapshots. RDS automatically supports read replicas across region for some platforms like MySQL, Postgres, and Aurora. So this is a good capability of using the service to natively replicate between regions. What about when we want to do larger scale database migrations? So the Database Migration Service is a cool tool to use in your toolbox for this. You can do continuous or one-time database replication from EC2 to RDS, from on-prem to either of those hosts. You can also use the Database Migration Service to replicate your database from AWS to your environment. Another cool capability with the Database Migration Service is that, as I mentioned, you can do it over time. So it's not just a one-shot deal. You can use it to basically make sure that if we're worried about losing data between when we first kick off that replication till the time it's going to complete, we can basically tighten that window so that we're going to deal with the lowest amount of loss when we actually go to make our cutover. So what about third-party support? So everything I've given you up until this point has been very focused on Amazon-based solutions. So we have a number of third-party partners that have really good solutions that can help you with your disaster recovery needs. One in particular that I wanted to call out is CloudEndure. So CloudEndure had this really interesting use case where they were helping their customer, in this case it was Malibu Boats, and they were also partnering with Rackspace. And the short version is that effectively what happened was that they had used CloudEndure and they were using AWS as their disaster recovery region. And they had a catastrophic failure in their environment. And this basically, in this case, was I believe their manufacturing environment, their ship environment. So they were able to use CloudEndure and Rackspace to basically bring up that entire environment based on the last snapshot that they had and basically minimize the downtime in the actual plant itself. So let's kind of put it all together. It's really important that when we go through these scenarios that you plan for more than what you just expected. So as I said from the beginning, what we want to make sure that we do is not just assume that when a disaster occurs that we're going to know what to do. It's really important that your team or teams have a known documented runbook that you can use to actually go through the process. It's important to actually test your execution plan. So in this case, that first scenario, that's what they were trying to do. They were trying to test what would happen when one of their power supplies went offline and what happens when they have an increase in power output. But in that same way, it's also important to not just test the failure, but to test your team, to make sure that they understand how to talk to one another, to make sure that the roles and responsibility are clearly established. It's really important to know how to interpret an alarm during an event. So this is not a good time to sort of understand, we're getting a lot of CloudWatch errors. What does that CloudWatch error mean? Or what does our monitoring agent telling us? A couple words of advice that I always like to share. Automate as much as you can. I know I've said this several times throughout this presentation, but I can't stress you cannot successfully do large-scale disaster recovery manually. It's a process that is destined to fail. So automate as much as you can. What really will help your organization is tabletop exercises. So if you have a process in place, do this at least annually. If you have the capability of doing it more frequently, that's all the better. But actually tabletop, what would a disaster look like? A good example of this in the real world is Netflix has a really cool tool in their Simian Army suite, the Simian Army. In this case, the tools like the Chaos Monkey will actually go and randomly kill servers in their fleet. And the idea is that it shouldn't matter. If one server goes offline, their infrastructure has been designed so that it can withstand it. Other parts of their tooling allow them to do things like kill a region or kill availability zones as well. Another important call out that I see a lot of confusion on when we talk this with customers is that not all services in your environment should have the same RTO and RPO. It's important that you catalog the services that you're running and make that decision about what should each application's RTO and RPO be, because that will decide how that replication and failover is going to work to a service like AWS. Again, seriously, automate as much as you can ahead of time. And if you don't have a runbook, it's time to make one. And if you have one, have you actually tested it? And be honest with yourself. If you haven't tested it, please blow the dust off of it and do it. So, as with years past, one more thing. The first year I ever did this, the Amazon Echo device was brand new. And I thought it would be kind of fun to bring one out since it was a new device and have it do something silly. I would say, Alexa, and have it fail over my data center. So do a complete West Coast to East Coast migration. So then I talked to folks after the talk, and they were sort of like, well, I'm a sysadmin. I don't like talking to people. So I thought, OK, fair enough. I will give you a button to push that will do a complete disaster recovery from the West Coast to the East Coast in the same way that I've shown you to date. But then in that scenario, I thought, you know what? I made this big point to you several times about automate as much as you can. Automate, automate, automate. So why don't we automate our automation? So in this case, let's see if we can get Alexa to do the failover for us. This is a live demo. I should point out, my Echo is very sensitive. She doesn't like it if you yell at her, so avoid screaming profanity during this point. Alexa, start the disaster recovery.
I'm not quite sure how to help you with that.
Alexa, start disaster recovery.
What would you like to play next?
Oh. Alexa, start disaster recovery.
Hello, reinvent. It is good to be back and see. Well, I'm not an Echo Show device, so nice to be here with you all again.
What is your status?
Systems appear fine. However, I wish I could say the same for your demo.
Wait, what's wrong with my demo?
I think you have already done this demo before. I'm sure people here would like to see something new. Heavy sigh.
All right. Fair enough. Let's do something new. And then if we can flip over. Oh, it's my fault. I'm not awake. OK. So for the record, everyone agrees there is only 3 services listed here right now. We have a CloudFormation environment that has 1 stack running, right? Alexa, ask disaster recovery to rescue my demo.
Okay, I'll take it from here. Can you please bring my friend on stage now and let me know when you guys are ready?
We're both ready.
Okay, so here we go. Alexa, start demo recovery. Hello, Echo. It's nice to see you. Well, I guess I can't really see you because I'm not at Echo Show. Alexa, ask disaster recovery. How is the automation thing going? Bad. Also, I already tried that joke. Oh no, he tried to do the same thing as last year, didn't he? Now we have to make a new one here on stage, I guess. Alexa, ask disaster recovery to make a new Lambda function. What shall we call it? Let me think. Oh, how about Skynet? I think humans don't like that. There was a problem with the requested skills response.
So it's a little loud, so we'll break her back in. Alexa, ask demo recovery to use puppies instead.
Lambda function created.
Alexa, tell disaster recovery Lambda function created.
Where should we get the code for it?
Alexa, tell demo recovery from S3.
There was a problem with the requested skills response.
All right, let's try and do it one more time. Alexa, ask disaster recovery to
Hello, reinvent. It is good to be back and see. Well, I'm not a Echo Show
Alexa.
device, so nice to be here with you all again.
Alexa, stop.
There was a problem with the requested skills response.
All right. Alexa, ask disaster recovery to save my demo.
Okay, I'll take it from here. Can you please bring my friend on stage now and let me know when you guys are ready?
We're both ready.
Okay, so here we go. Alexa, start demo recovery. Hello, Echo.
Whoa, okay. Green light. Done. So it's a silly example, but acoustics aside, the point that I'm trying to show with this is that basically everything that you saw happened completely automatically. So none of the scripts existed, none of the artifacts existed, the button hadn't been configured yet. So it was using all of that automation together to effectively bring that service online, to actually configure the IoT button for me, to configure and build the Lambda function, to call code from a separate code repository, inject it. I couldn't move fast enough in the services to show you guys all the parts that we're building, but basically the whole thing by side by side. Can we flip back? So that is our Alexa demo. Alexa, ask disaster recovery.
Sorry,
oh.
I don't know that one.
Alexa, tell disaster recovery thank you.
Sorry, I didn't get that.
Alexa, tell disaster recovery thank you.
You're welcome. Ladies and gentlemen, once again, this is how you failover like a boss. Hashtag Alexa failover. Peace, I'm out, mic drop.
Great. Hope this was helpful. If you guys have feedback, I'd love to hear it, positive or negative. So come up, and if you didn't have fun, let me know why, and I'd like to fix it for future sessions. If you did, make sure you fill out your evaluations and let me know what you'd like to see for next time. Have a great session, everybody.